Welcome back, everybody. Welcome back to the channel. So today we're going to start talking about how to compile different things. So I'm going to go to the CMake list file, comment that out, and we can kind of see where we're going to go from here. So go to compiler.cpp, search for compile. So we're going to need to do a couple things before we actually start. In today's video, all we're going to really do is we're going to be talking about how to basically compile a module declaration. It's going to be a relatively light amount of work for compiling a module declaration, but we still have to do some preliminary setup so that we can get our compiler up and running. So as I mentioned before, we have this setup function, which basically just does our basic setup for all of our lists. We of course want to set up our basic types. So if you guys remember, each U-type has this data constructor where we have a default of it not being an array and we pass it the type. So we want to just create a nil type, a var type object, and a null type because we want to basically reuse these U types across our code because they're going to be one of the most used types in our compiler. Also, we want to, of course, create an undefined type as well. So if we don't know what something is, we want to use that as well. Now, here's something I want to make very clear. When we're doing various things in our compiler, like as you can see, I've already talked about this before, right? Adding a module, but I want to make something very clear that I don't think I mentioned in a previous video. If you notice here, I put a $sign. The reason for that is, and you're gonna see this kind of around a lot of bits of the code where I have what's called a internal entity. And I'm putting air quotes because I made up that word. Basically in my compiler, what an internal entity is anything that represents a internal piece of information that only the compiler cares about and the user should not nor have access or care about what or why it's doing what it's doing. So as you can see, I have this SRT undefined module, which is going to represent a undefined module. So in our programming language, we're going to have to specify at the highest level or at the very top of our each class or each file, we have to initially specify the module as like the first thing. So if we don't do that, then we're going to use this undefined. But the problem is the user technically could create a SRT undefined module. So this is just a simple example, but there's going to be other examples where you just want to make sure you don't override what the user has potentially could have already written. So once we did that, that's a little bit more of a rant than it probably should have been. So I'm going to go back up to compile. After this, we want to randomize our GUID. The reason why we want to do this is to, again, make our code secure. If you guys remember before, when I had my executable file, where is it? So if I go to syntax ODF, so if I have my executable file, if I scroll all the way to the top, you can see here that I have a bunch of different classes. And if I set this to obfuscate, each of these classes will be obfuscated. But if you want to do it from build to build, you have to do a true random number. So if we look here, we have our generator. Now, I'm not going to pretend like I know what the hell is going on. You guys can just copy the code. Honestly, all this does is this. We basically get the current epoch time in nanoseconds, which is the UTC time in nanoseconds. So it's basically how many nanoseconds has it been since, what is it, 1971 or whatever. Don't remember, but that's what that does. And we just shifted right 4 bits so that way the number isn't so large. And we'll still get an accurate number, and it'll be completely unique. The reason why we want to do this is what we're doing is we're setting the seed. As we move with time, we want the seed to always change because time moves forward forever. So we always want to guarantee that the seed is going to be unique. So that's how we do that. We create this generator here, and then we create a uniform distribution, which is going to be the main thing that we're going to use to generate our actual code or actual number. And we basically create a range of 1 to 100,000, and then we just set the GUID to that value. So you guys can copy this code. You can do a search for randomized GUID. It's going to be in my compiler file, which is located in the grammar backend compiler.cpp. These two files for the rest of, I don't want to say for the rest of the YouTube series, but for quite a while, we're pretty much going to be talking about everything in these two files. So if you want to find anything that I'm going to be talking about from now until like the next however many episodes, you're most likely going to find that in either here or potentially C or compiler2.cpp. So that's how we do that. Just make sure you do that. It's very important. Now, here's where we get into the various compiler stages. We are going to have to do a couple different things. We're going to have to pre-process, post-process, and then compile everything. You absolutely have to do these stages because there are certain things that you're not going to be able to do at certain stages, and you need to control what the compiler is actually going to compile. Now, I'm just going to put this out there, and I know probably some of you are wondering, no, my compiler is not multi-threaded. It's a single thread, so it's going to compile everything sequentially. I'm looking to potentially have a multi-threaded compiler on 0.3.0 when we kind of improve on the language in 3.0, but we'll get to that bridge when we cross it. So the first thing you want to do is create this preprocess function. You want to set your processing stage to pre-processing. Once you do that, you want to have a success flag or success boolean, and you want to create a for loop where you loop through every single parser in our file. Every single parser in our compiler is going to basically represent a single file, and each file is going to have a set of ASTs that we can traverse to read and process information. Now, I will mention that we are not going to process everything all at once and just be done. That's not how it's going to work. We're going to be compiling every single file and traversing each AST multiple times during the compilation process. So it's like we're going to basically scan each file several times and scrape a little bit more information about that file each iteration. And that's basically how it works. So you want to create this list here, and we want to basically set the current parser. So the current parser is what we're going to be using in multiple spots in our compiler. And you want to do what's called update error management instance. The reason why you want to do this is because we are expected to have a single error management system. I originally did not have a single one. This is some new code that I recently added. But basically what you want to do is check to see if the error management system is null. If so, you want to create a new error management system. You want to pass it the reference to the lines. Now, it's a reference, so it's a pointer to the actual lines. We don't want to, when we pass in the lines here, we don't want to pass in a new list and copy all that data because we're going to be copying all those strings. So in order to be efficient with memory, you want to pass a reference. You want to say what file is it. You want to pass whether or not we are going to print as is, and aggressive errors is whatever the user set. Now here's something that's different than our parser. Before, when we had our parser, we had all these fancy things, right? We had the ability to enter protected mode and like check to see if the user maybe meant this thing. And if they didn't, then we like rolled back those errors and we like tried something else. And we really tried hard to figure out what the user was trying to tell us in the actual code. Well, when we get to the compiler side, we don't care. We're just going to print, like if there's an error, we're just going to print it out immediately. So that's what this as is true for. We want to just make sure that once we get an error, we print it immediately. Otherwise, if it's already present, then we want to update the error management system. So we pass in our parser, as is to true, and aggressive errors. And all this function does, like I said, is a new function. We basically check to see if the parser is not equal to null, and we set the new set of lines to the reference of the lines that the parser is going to be pointing to. And that's basically the same amount of lines that is inside of our tokenizer. And then we have our file name, so we want to update our file name, set whether or not we want to print errors as is, and whether or not we want to print aggressive error reporting. So once we do all of that, that's kind of our preliminary setup for our error management system. We want to add this file, so we want to basically get the current tokenizer or get the current parser, get the current tokenizer that's attached to that parser, and then get the file that that tokenizer is representing. And then of course we want to set it a unique ID. Now I will say this, we only do this once. So we're going to pre-process everything. We're going to add every single file one time, and that's it. Um, so after we do that, then we want to basically have a check for errors. So we want to set our total errors, and we want to get the current amount of errors that were processed already. So the reason why you want to do this is at the very bottom, we want to check to see if there were any new errors found, which basically just takes the current amount of total errors we have, subtracts it from the variable we just created, and if so, if it's greater than 0, that means that since the last time we recorded what the original state of errors were, there were more errors created after that. So obviously that means there was something wrong with this file or something. So we just want to set success to false, and we want to add this current parser to the failed parsers. Now this says add if. What add if does is checks to see if that element exists. If it does, it returns out of the function, otherwise it adds that value. So we do all of that, and if we scroll back up to the top, we want to basically add our current scope. So this is where we're going to start adding scope. And this is going to be the first scope that we're going to add. It's going to be a global scope, and we're going to pass it null. The reason why you want to pass it null is because the expectation is that at the top of every single file, you're going to specify the module. Once we specify the module, we can know which global SRT class to get to be able to access that instance and set that as the current class scope that we're inside of. So when we go back, we set that to null, and then we just basically for loop through the size of the current parser. So size returns the size of the tree or the ASTs that are inside of that parser. So we want to for loop through all of the high level ASTs, and we want to get each branch individually, and we want to basically just say if the x is equal to 0, so if we're at the first AST, we want to check to see if the current AST that we're processing is a module declaration. If so, that means that the user has successfully followed the rules and added module to the first thing of the file. And if so, we want to get the package by parsing a module declaration. And what that does is we pass it the branch. So we're going to pass it the branch that this module is defined at. And we just literally for loop through all of the various different values in there. Now, if we go back to our parser, you can actually see this in real time. So if we say parse, was it module declaration? So if we go to parse module declaration, you can see it has at least one identifier, and then it's just a for loop with dots and identifiers. And of course, if you notice, we keep the dots because that's important. Um, so if I go back, and sorry if I'm going fast, there's like a lot of stuff we have to go over. So compile, preprocess, and parse module. Yeah, so once we parse our module declaration successfully, we're going to get the package, we're going to get the string value of the package. So once we do this, then we want to add the module. So we want to add this package, assign it a unique serial number, and then we want to set the current module, and we want to get that pointer. So once we add it, we can just call get module and get that pointer from that list. Now, ideally, this is inefficient. If we're going to add the module, we're literally creating the pointer to the module. It's probably better to just return it here because it's more efficient. So that way you don't have to like go through the list 2 times. But I'll probably fix that later on. But yeah. Once we do that, then we want to do what's called create a global class. Now, I'm going to skip over this because that's going to take a little bit more time. I'll explain that after. So once we create our global class of SRT global, then we want to basically we want to get the current scope, and we want to get the last scope created in the list. Now, we just created it, so it's going to be this one, this pointer here. We want to set the class to finding the global class. So I'm also going to explain find class shortly in a second because that's kind of related to this function. But in short, we pass the module that we're inside of based on the code up here. We pass it global class, which is a static variable, which is SRT global. And this is where you guys can start to see, this is how I enforce SRT global. So like if you have like a static field or something, that's how everything is put inside of that class. Um, and then we pass it the classes list. So this is our list of classes in our compiler. So once we do all of that, then we just hit continue, and then we just go through and we process everything else. Otherwise, though, if the user did not put a module at the first as the first thing in our file, then of course we want to complain about it. And notice I don't have a continue down here because I obviously do want to process that information. But I set the current module to undefined module, which if you remember, this is the pointer to the module data that was set up in our setup function. So that should already be populated with the address to that module. And then we create the global class underneath this undefined module class, or this undefined module name. And then we set the current class with the same code that we put up here, where we just find the class of the global class. Ideally, again, you'd probably just be better to just return the global class from this function, but it's whatever. So yep, we have that, and then of course we want to create an error and say it's going to be a generic error. Now, one thing you're going to start to see in my compiler, as you know, I do have a set of canned errors, but as a compiler developer, it is nearly impossible to create a standardized list of every single possible error that we're going to encounter in our compiler, because compilers change, right? Like, you add features, you take out features, and it would just be a mess. So I use generic errors, which basically doesn't print anything. So like typically all of these other errors, they have a prefix of text. So like, for instance, unexpected symbol, it would have a prefix text of unexpected symbol, and then I think like a colon. And then after that, this part of the code here, or this portion of the string, would be what the additional message would be after the error was fully generated. So, but generic doesn't return anything in terms of like a postfix to the actual error message. So we're going to be using generic errors all over the place, and we want to say module declaration must be the first in every file, because obviously we want to enforce that. You guys don't have to do that, but I just prefer to do it at the first point, because otherwise, if you didn't, you'd have to keep track of how many times you process the module declaration, and that's just messy. Um, so after that, we have our switch statement of a branch type, and we have all of our various different branches. Now, we're going to get into this in a later episode, but when we are basically pre-processing everything, we're going to have a limited scope as to what we can pre-process, meaning that we are only going to be pre-processing classes, fields, aliases, and enums. We're not going to do functions. We're not going to do mutate declarations. We're not going to do anything else. But what I will say is that at the very beginning, so obviously you're not going to have any of this code yet because we haven't gone over it, but do put this default here in error out and say unknown AST of type, and then put the type of the AST, and then create a new internal error. Now, internal error means that it's something inside of our compiler. It's not something the user has done. The reason why you want to do this is because starting out, when you are first coming into this code, you're probably going to screw up something in your parser and code will be mangled. So you just want to make sure and put this as like a training wheels for the first point. I don't think I do this after the pre-processing phase because it doesn't make sense to, but you just want to make sure that your code is coming in correctly. After that, we want to check for any compiler errors. That's what check CMP errors is. If so, we return false. And what this does is it checks to see if we've panicked. If so, we want to run this exit proc or this exit procedure. Otherwise, if we get the unfiltered errors or the total amount of errors, we want to see if that's greater than the sharp C error limit or the sharp compiler error limit. And all that is the C options error limit. So if you guys remember, the C options limit is, I think, like 1,000 or something. Where is it at? I don't remember what the file is. What is it called? Options. OPTION. Yep. So if we go to our options and then we see, yep, error limit here. So it's 1,000. Yeah. So if the user has more than 1,000 errors, or if they manually updated it to some other lower or higher number, then we want to basically set panic to true and run the exit proc. And as you can see here, here's a glimpse of some of the limits. By the way, we have a bunch of defined statements down here. We'll go through them as time goes on, because it doesn't make sense to go through them all initially, because they're not going to make any sense because we don't have the code to be able to process the information anyway. So I'll do that one by one, but here's something interesting. Like, you can see I have limits for classes, for fields, local fields, thread locals, so on and so forth. So you guys can check this out in my compiler if you guys are interested. It's in the header file. But yeah, we'll talk about that a little later. So if I go back to my compiler, so once we've done all that, right? Once we've done all of our basic setup, we've created our global class, we have this find class function, and all of these various different things in our switch statement, obviously negating this, just the default value. Then what you want to do is you want to call remove scope. And what that does is that gets the last scope. You want to reset the local scope flags, which I think actually frees up some information. Yeah. So it's going to call free on a couple different items. So you can free up that memory, and then you're going to basically just delete the last scope and then pop the list back. So that's how you remove a scope. But yeah, so that's going to be it for parsing a module declaration. Now, obviously, we're going to talk about this after we kind of get through everything. We're going to have to talk about how handling imports and base classes. We'll do that probably after we talk about all of this code. But let's look to see now how we create a global class. So in our global class, we have this create global class function, and we set our flags to public extension. The reason why you want to do that is because you don't want the user to be able to instantiate the global class because it's going to be a really big class. It's going to basically hold all of the static fields of everything. Not to mention, it's only going to hold static information. So if you instantiate it, it's going to be empty. So there's really no point in that. This is just personal preference. I don't see a point in the user actually using this class. So yeah, that's why I did that. And we'll see how I enforce rules on that later. But after that, we want to call find class. So in order to, this is going to be the first function that we're going to see in our compiler for how we resolve information. So this is how I resolve classes. This is one of the ways, I think, of how I resolve classes in my compiler. You need to pass it the module. Now this of course could be null, which is totally fine. You pass it the name of the class, a list of the classes you want to traverse, and then match. The reason why you want to say match is because in my compiler, I actually have a helpful hint where if you misspelled the name of a class, I will error out and say, I don't know what this class is. However, did you mean this class or this class? So that's what match does. So what we do is we say class object of class, we create a found variable, and we just for loop through all of our classes, and we get the class, and we if match is true, then we basically want to see if the name of each class, if the class name that we passed in is inside of the name of each of these classes. That's why if it's not equal to in position, that means that we've successfully located this class inside of this name, and then found will be assigned to the appropriate value. Otherwise, if we're not trying to match, which I think by default it's set to false. Yeah. So by default it's set to false, and otherwise found is going to be equal to the name of the class being equal to directly the name that you passed in. So if we found it, then we set found to false. And the reason why you want to do that is because there's potential that neither of these if statements can be processed, right? So if we basically, we'll have like two cases. So we'll have the case where module is equal to null, meaning that we don't care about where this class is located. We just want to find it. Now, what this will do is if you have a series of imports, and let's say you import class or import module A and then module B, and module A and B has the same class with the same name in it, we're going to access whatever the first class that the compiler ran across when it was actually compiling it. So let's say we compiled everything in module or pre-processed everything in module A first before we got to B. Then when you access the class, we're going to be accessing the class in module A. Now, if the user obviously wants to alleviate that issue, then they're going to have to specify which module the class was defined in. So that's why I have this. So if the module is equal to whatever the module is, then we return the class. Otherwise, if the module is not equal to null, we return the class. So that means that this is why I was saying like these if statements might not be accessed. There's a potential that module is not equal to null, and like the module that's inside of this current class that we just found is not equal to the one that we passed in. So and it's really cool because we're just comparing pointers, so we're not doing like string compares, so it's a little bit quicker, which is really nice. So once we do all of that, then we want to check to see if our global class is equal to null. If that's so, that means that we do not have a global or an SRT global created for this specific module. So what we do is we say add global class object. We pass it the global class or the name of the global class, SRT global. We pass it the flags. We say AST is null because there's not going to be any duplicates, so we don't have to worry about that. And then we pass it classes. So it's going to be defined inside of our classes list. And then what we do is we go here. Now there's a bunch of code here. So first we create what's called the metadata. All it does is it passes in the line that it was defined on, the file that it was defined in, the line number, and the column number. So you can see that here. I'm checking to see if AST is equal to null. If so, I put 0. Otherwise, I put the respective data. So once we do that, then we want to, and this is pretty self-explanatory, we basically want to create the class. We pass it the basic information. We need to know the name, the module, the serial number, the flags, the metadata, and we also want to create a previous class um, variable. And once we do that, then we want to check to see in two different ways. So this is where it gets a bit weird. Again, there's some strange stuff in my programming language. This kind of dates back to a really nasty bug that I had before. It's not there anymore, but I just left the code in. Basically, I had a bug in my old compiler where you could create a class of K, and it could be a generic class, and then you could also simultaneously create a class of K and just be a regular class. And these would be considered two distinct objects, which makes no sense. So you're going to see that here in a second. So first we check for the normal name. So we check this, we pass in the module, the current module that we're in, the name, and then the class list. If we find it, great. Otherwise, we check to see if the class was defined by adding this keyword, these two brackets, or these less than and greater than symbol here, which basically means that this is a generic class, because that's how generic classes are created. And also, by the way, really quick, so the way that I name my classes, obviously, like the way I name class K, or let's remove the confusion. Let's say this was class Apple. It would be just, what is it? I'm in the module app, so app hashtag Apple. That's how the name of the class would be defined. However, there's going to be two ways that I define the names of generic classes. So initially, when I pre-process the generic class, I need to get the basic information about it. So that way, when, like, if I say, this apple represents a base of class K of type var, then I want to be able to have the basic information to be able to create this generic class. So the name that I create for what I call the generic owner, or the God generic class, is, there would be app hashtag, what is it, K. Yeah, so this is how the name would be without the keys in there. This is the name of the actual class that will be generated, and then if we generate like the K of var, then it will be app hashtag K of var. So the reason why I don't put the generic types is because theoretically you could have a class of T. So I just put this just to be safe. And yeah, so if we go back, we can see here that I just add this postfix to the name. And if that also exists, that means that obviously we're creating a regular class when there's already a generic class with the same exact name. So if so, we say previously defined class name is already defined in module, and then we say current module of name. And then we do what's called printing a note. So what notes are basically, it's a way for us to explain to the user important information when there's an error that is related to something else in a different location in our source code, right? So if, for instance, we have this example where we have, class whatever is previously defined in this module, we want to know where that class was defined at. So we're going to print a note to link to where that was defined so that the user can click on that link and then go to that file and do whatever they need to do to fix the bug. So the way we do that is we pass it the metadata and the message. So we say class full name. So we put the full name because we want to be absolutely sure to the user that this is the class that broke, and it's previously defined here. So once we do that, then we basically check to see if the last note message is not equal to null. What that does is that just makes sure we don't keep printing the same notes over and over again. We also want to check to see if the lines are not equal, and we haven't already printed the same note for a different other error or something. So if all that's true, then we say notes, we create a string stream in file, we put the name of the file, colon, the line, colon, the column, colon, and then note, and then the message. then inline, and then here's how I basically print out the where the actual error happened. So if I broke something in the code, if I say like put a T there, run the compiler, and it's going to take a while, but I'm going to just go back to the code while that kind of compiles. So the way that I do it is I put a bunch of tabs. I say here's the line, so I print out the actual string value of the line, and then I put a bunch of more tabs, and then I basically for loop all the way up until just before the column, and I put a bunch of spaces, and then I put the arrow. That's how I'm able to say, okay, it broke here, because this code actually works perfectly because we just go up to the last character right before the column. After that, I print out the note message, and then after that, I set the last note message to whatever the message was and add this message to the list. Once we do all of that, if we scroll back down, you can see here that if this file was previously defined, obviously this instance is bad. We want to destroy this instance, so we free up this class, and then we delete that instance, and then after that we want to return the value of the class. So we want to check to see if the class does not end with this less than and greater than. If so, then we want to return whatever the previously defined class is, otherwise we return null. The reason why we do that is because technically speaking, generic God classes do not exist within inside of our compiler. Technically, they're like phantom classes. It's a bit of a weird concept. We'll get into it later. I don't want to really go too much into it now. But after that, we also check to see, so if we tried to locate the class and we couldn't locate it, then we check to see if the class ends with, or the name of the class that we're trying to create ends with these values. So if the name of this class came in as, K, so if we came in as K of this, then we want to strip those two K characters, or those two less than and greater than characters, and then if that file exists or if that class exists, we want to go to previously defined and print out the error. Finally, we're down here, so we're finally done. So what we do is we set the owner to the global class. And this is how I basically have the ownership versus inheritance, where we basically say, all right, the global class owns this subclass. Even though it is technically a global class that is created, the SRT global will own that class. Now I know what you're thinking, right? Like, wait a minute, weren't we just talking about creating a SRT global? Isn't this going to be a problem? Well, no, because if you notice, I added after the fact. So I'm not going to set SRT global to own SRT global, because obviously the class doesn't exist in the current module, because that's why we're here in this function in the first place. So this is going to be null if the class is SRT global. It's not going to be null if it's a regular class. We check to see if it's not equal to null, and then what we do is we add this class to that SRT global class. The idea behind that is, like I said, this is equal to null if it's SRT global. If it's not equal to null, then it's a regular class, and we just want to add whatever this regular class is as a subclass to this one, and then we basically will allow the user to say hashtag SRT global or hashtag main SRT global dot whatever. So after that, we basically set up the AST by setting the current AST to where the class is basically defined at. We add this to the list and we return that pointer to that class. Once we go through all of that, let's go back, preprocess, what was it, create global. So once we go through all of that, then we want to set the address. Now this is how I set addresses to my classes. So if I go to my where is it? My syntax file. If you notice here, every class has an address. So, and by the way, this is really cool. I've been doing testing with my optimizer, and I'm able to gain a net 10% efficiency, meaning that I get a 10% boost in performance from the actual code, but that's beyond the topic of this video. Anyway, as you can see here, SRT Global for app has a address value of 0. Test class has an address value of 1. And this makes sense if you look at how the compiler is processing this information. We start here, we immediately process this app, then that prompts us to create the global class for that module. And then the next class that we process is this test class. and that's set. We set the address to that test class and then go from there. It makes sense that this K is not going to offset the addresses of all of the classes because theoretically it hasn't been created yet. This is why I say generic classes are kind of phantom classes because they don't affect the address base of all of our functions and everything else until the class gets created. Hope I didn't confuse anybody with that, but we basically just set the address by saying class size plus plus, and after that we set this to a global class because obviously we want to make sure that it's a global class. We're going to use this boolean later on in the code, and then here's how we set the full name. So we say whatever the current name of the module is, hashtag the name of the global class, and then we say global's full name is equal to this string stream, and then we add a default constructor, and then we free up the flags. Now, if I go to add default constructor, we want to pass the global class that we create, and we want to pass it the AST. Now, this, this function is really complicated. I don't want this video to drag too long. So here, I'll just kind of go through it. So this is basically exactly the same thing as our resolving classes function. It's slightly tweaked. So the way that I do it is I basically create a list of empty params of fields, create a list of access flags, and then basically I set it to public because a default constructor is typically, it has to be public. And then you set the name of the function equal to the name of the class because that's how it works. When we create a default constructor, it's going to be the name of the class as the function. And then we want to set up our metadata. It's exactly the same way we just did, so I don't have to go over that. And then we do something very important. I actually just fixed this bug like an hour ago. Basically what it does is we want to check to see if the class is a generic class. Now what this does is this basically takes the current number, shifts it 1 bit, and compares it against 1. So what it does is it checks what we're basically doing is checking the generic class bit, and the value of that is equal to 2. So if we go here, I clear this, 2, the value of whether or not the current type of the class is a generic class, the value is 2, so we want to check this bit. So what we do is we just shift, check, and then check to see if that value is equal to 1. If that bit is enabled, then it must be a generic class. Then what we do is we want to set the function name equal, we want to set the function name equal to the generic class substring minus the two like crabby things, for lack of a better word. Um, so we have like k again of this. We want to move it to, or we want to set the new name of the function that we're looking for to k. So in the way that we do that is we get the generic owner of the class. So we don't say class dot name, right? Because we could have a k of var, and if we do a substring of 2, it's going to end up being k of this. So that's not going to work. So because we know how the generic owner's name is structured, and we know it's going to be k of that, we can rename it to k of this as the name of the function. So that's why we do that. And we basically try to locate the function. Now I'm going to go into that function in a little bit, but once we, like if the function cannot be located, meaning that the value is equal to null, then we create the method by passing it the name of the method, which is the name of the class, the current module it's in, and actually that is a bug that I just found. Okay, so you want to pass it the function name. So you want to create a method, pass the function name as the name of it. You want to create the current module, current class, and then of course the serial number, the empty params, any flags, and the metadata. Once you do that, you want to set up your preliminary information. You want to set the full name by getting the class's full name, putting a dot, and then the name of the function. You want to set the AST of where this function was defined. Then you want to set the type of the function as a function constructor. You want to set the address by saying method size plus plus, and you want to set the utype to a nil type because the assumption is that constructors return nothing. And then after that, you want to just add the function to the class that is defined in. So is that everything for creating a generic class? Because I think this is the last thing we need to talk about. Yeah. So I'm going to go back to this function. Now, I don't want to go into this now because it's really complicated. As you can see, this is a really long function. What it does is we basically try to locate and resolve a function based on tons of data we pass in. So we need to pass it the class that the function was defined in, the name of the function, any parameters that the function is supposed to have, the AST, this is just for error reporting in case like the function call is ambiguous or whatever. Whether or not we want to check the base class, the type of the function. So if we put function undefined here, then what effectively will happen is we'll just try to resolve any type of function with the name that we pass in, and then whether or not we want to do an advanced search. So this is a pretty in-depth function, and there's still some bugs with it, but yeah, it's just create this function. So create it returning a method, find function, class object of k, string name, and obviously all of these parameters. And we will go over this function shortly. So I'm actually going to put a to do here. I'm going to say to do go over function in tutorial later. So we'll talk about this later because, like I said, this video is already too long, and I just wanted to get the preliminary stuff out of the way. So that's going to be everything. We've pretty much gone over how to compile a module declaration. So that's going to be it for today, guys. As usual, if you have any questions, definitely write them in the comment section below. As usual, if you guys would love to help support the channel, definitely head over to my GitHub repository at androidevcity/sharp. And when you do, definitely watch, star, and fork this repository. That's going to give this language a lot more visibility and let other developers know this language exists. Also, if you're curious about learning what I've been up to on a daily basis, as you can see, I update it pretty regularly. You can head over to the remastered branch, and I write some pretty wordy commits so you can kind of get a gist of what I've been up to without really having to look into the code. Also, if you guys are curious about learning maybe some of the things that I've done in the past to the language or stuff that I'm looking to add in the future, you can head over to the docs folder, and there's two main files you can check out. There's a change list, which is basically anything that I've done in the past, and the roadmap is not only that, but also things that I'm looking to add in the future. So I definitely would recommend checking out this file. It gives you a lot of insight into the language, so on and so forth. So that's going to be it for today. As usual, if you guys are new to the channel, definitely consider subscribing, and until next time.